Welcome to this explainer. I am absolutely thrilled you're here because today we're going on a bit of a journey. We are going to fundamentally transform how you think about artificial intelligence. We're moving way beyond just understanding a single AI agent, and we're going to learn how to manage a massive automated agency. And the best part? You don't need a computer science degree for any of this. If you've ever felt like your AI outputs are, well, kind of underwhelming, or if you're curious how the pros orchestrate entire virtual workforces to accomplish in minutes what takes humans hours, you are exactly in the right place.
Okay, let's dive into our roadmap. We'll be covering 1. Anatomy of an agent, 2. Memory and prompt contracts, 3. Multi-agent orchestration, 4. Consensus, debate, and review, and finally, 5. Managing the context window. So, Section 1, Anatomy of an Agent, beyond the chatbot.
To really grasp this concept, think of the standard AI chatbot, just the raw large language model, as a caveman with a spear, right? It has a brain, it has intelligence, but it's completely isolated. An AI agent, on the other hand, is that exact same intelligence, but surrounded by the infrastructure of modern society. It's the LLM, plus tools like web browsers and file editors, plus persistent memory, plus reasoning loops. That architecture built around the intelligence is what makes an agent truly capable of acting in the real world.
Under the hood, an agent functions on a continuous core loop. Step 1, observe. The agent reads its context, its files, its environment. Step 2, reason or think. It forms a mini plan on what to do next. Step 3, act. It calls a tool, edits a file, or runs a web search. And it loops these 3 steps over and over and over again until it strictly hits step 4, a predefined definition of done. Because if you don't give it that definition, it just wanders. But when you do, it becomes a relentless worker. While the underlying intelligence of the top models out there is actually very close, their slight percentage point advantages make them distinct employees with totally different skill sets. Claude, for instance, is incredibly interpretable, making it the perfect manager or orchestrator. Gemini excels at front-end design, UI, and multimodal video understanding. Meanwhile, Codex is your absolute powerhouse for back-end programming and test-driven math. You don't have to choose just one anymore. You literally hire the best specialist for this specific task at hand.
Section 2, Memory and Prompt Contracts, Taming the AI.
How do we actually control these things? The answer is self-modifying memory. This is a total game changer. By setting up a simple hidden markdown file, like an agents.md, you can have the agent automatically write down rules based on your feedback. So, say you reject a dark mode design once, and you tell the AI you hate it, the agent updates its own memory file. In every single future session, that rule is automatically prepended to your prompt. The AI literally learns your preferences session to session and never makes that exact same mistake again.
But we can take this a step further. What if, instead of just guessing what you wanted, your AI actively interviewed you before doing any heavy lifting? This brings us to reverse prompting. Instead of throwing out a vague command like, build me a website, you force the agent to ask you 5 clarifying questions. This surfaces all your hidden assumptions and constraints first. So the crucial point is how you lock those answers in. We use what's called a prompt contract. Before the AI writes a single line of code or drafts an email, it actually drafts a contract defining the exact goal, the constraints, the output format, and most importantly, the failure conditions. Forcing the AI to sign this contract with you eliminates those vague requests and almost guarantees a high-quality, one-shot result. Section 3. Multi-agent orchestration, building an agency. Let's see how this builds into the orchestrator pattern. Imagine Claude is the boss. You hand Claude a complex project, let's say building a new software app. Claude takes your prompt, breaks it down, and delegates the front-end UI design to the artsy designer, Gemini. Then it shuttles the back-end API tasks to the nerdy specialist, Codex. Claude just manages the communication between them, perfectly exploiting those unique strengths we looked at earlier. And the delegation gets even wilder with the video-to-action pipeline. AI agents can now learn from the exact same medium that humans do, video. In this pipeline, you give the orchestrator a YouTube tutorial. It passes the video to Gemini, which natively watches it frame by frame and extracts highly specific step-by-step instructions. Those instructions are handed back to Claude, which uses its tools to actually execute the steps on your computer. It is entirely autonomous learning and execution. 50. I want you to remember this number. While a single AI agent might manually navigate a website and fill out maybe half a form per minute,
Orchestrating multiple agents completely changes the game. By scaling up to 100 parallel Chrome browser instances, you can yield 50 completed forms per minute. Speed and parallelization are the true superpowers of agentic AI.
Section 4. Consensus, debate, and review. Swarm intelligence.
Now, what's really interesting here is the concept of stochasticity. Basically, every time you ask an AI a question, there's a slight statistical variation in its answer. If you only ask once, you get a really narrow slice of possible ideas. But if you spawn 10 parallel agents, each with a slightly varied prompt, you exploit that stochasticity. You traverse the entire search space of possibilities, allowing you to farm brilliant, outlier ideas that a single, naive search would have completely missed.
You can even throw these agents into a shared chat room together by assigning them specific personas, like, say, a systems thinker, a pragmatist, and a contrarian. You force them to debate each other. They push back on lazy assumptions, they argue over the nuances, and they carve out highly refined solutions before they ever present the final idea to you. It's literally like having an executive boardroom working at lightning speed. This kind of peer review is also critical for catching mistakes. You see, when an agent spends thousands of tokens working on a problem, it develops a sunk cost bias. It assumes its way is the best way just because it spent so much time on it. Sub-agent verifications solves this. The implementer writes the code, but passes the final output to a fresh reviewer agent with zero context bias. The reviewer objectively catches the mistakes the implementer was totally blind to, and then a resolver fixes them.
Section 5. Managing the context window. Infrastructure and survival.
Let's think about the hidden cost of powerful agents for a second. Imagine a 200,000 token limit. Think about how much of that is already eaten up. A massive chunk goes straight to system prompts. Another slice goes to your memory and rules. And a huge slice goes to loading the actual skills and tools. All of this is consumed before you even say hello to the model, leaving a surprisingly small slice for the actual conversation.
And as your token count climbs toward that limit, the quality of the AI's output really starts to degrade. Eventually, you hit auto-compaction. The model is essentially forced to squish the context down to save space. While it technically keeps the conversation going, critical nuances, specific instructions, and vital details might literally be squeezed right out of its memory, leading to major errors.
To survive this, advanced users employ the iceberg technique. You don't load your entire 10,000-line codebase natively into the context window. You keep only the absolute critical rules and memory above the surface. Everything else, massive databases, full codebases, web access, remains below the surface. You simply give the AI a tool to search and read only the specific snippets it needs, purely on demand.
Which brings us to our ultimate takeaway. An AI is not just the raw intelligence model. An LLM alone won't last long on the savannah, right? The true power of agentic AI lies in the architecture, the memory loops, the tools, the swarm peers, and the context management we build around it. That infrastructure is what turns a simple chatbot into an unstoppable digital agency. We've gone from the basic core loop of a single agent to managing an interconnected workforce operating in parallel. So I want to leave you with this provocative thought. If you can orchestrate an entire workforce of AI specialists right from your laptop today, what will you build tomorrow? Thank you so much for exploring this fascinating topic with me. Keep learning, keep building, and I'll see you in the next explainer.